Alright, so today we're going to be talking about rational equations in section 6.6. Rational equations are an extension of what we've been talking about with rational expressions. Remember, rational expressions are just those really big fractions, okay? And so we're going to be putting rational expressions in equations and solving those equations. So just remember, these rational expressions here, these things are just really big fractions. Okay, the things with the polynomials on the top and polynomial on the bottom, right? Yeah, we kind of looked at those. So to get a feel for how to solve these equations, and they're going to look pretty nasty by the time we get to the harder ones, let's take a sort of a review example, something we talked about way back in chapter 1. We solved linear equations, and they just had some fractions in them. Things like 2/3 x minus 1/2 equals 5/3. Okay, this is just a review example, but I think it will help to get the ideas down for what we need to do. Remember, the first thing we did, and I'm just going to speak as though you guys kind of remember some of the stuff because we talked about it before. First thing we did is to find the least common denominator. So you got three fractions here, and in this case the least common denominator is 6. So the first step is to find the LCD. In this case the LCD is 6. Just make a note of that. Okay. So the second thing, once we found the LCD, is we multiply both sides by the LCD. Multiply both sides by the LCD. And remember, when we multiply both sides of an equation by something, that thing will distribute to every term. So really we're just multiplying every term by that LCD. So multiply every term. That's really what we're going to do. So I'm going to take the 6, multiply it to every term. I'm going to change the color up here. Let's multiply 6 on the first term, multiply 6 on the second term, and multiply 6 to the third term. Now remember that 6 is only multiplying the top because essentially it's 6 over 1, so the 1 would go to the bottom. And then we can go through and reduce each of these fractions. So the third thing we're going to do is to reduce fractions. Okay, so I look at this and I can see that 6 over 3 reduces, right? 3 becomes a 1, the 6 becomes a 2. The 6 over 2 reduces, 2 becomes a 1, the 6 becomes a 3. And the 6 over 3 here reduces as well. So the 3 becomes a 1, the 6 becomes a 2. And so once I've reduced the fractions, I then go through and simplify and solve, right? So simplify and solve. And now we won't have any fractions because all of my denominators are 1. So if I just simplify 2 times 2 times x, I'm going to get 4x for my first term. Then I have 3 times 1 is 3 with a minus, so it's a minus 3. And then on the right side I have a 5 times 2. That should equal 10. So 4x minus 3 equals 10. We'll just solve that. Add our 3 to both sides. 4x will equal 13. And divide by 4, so x will equal 13/4. Now normally we would just throw that into our solution set and be done with it, but with rational equations we're going to want to be careful. And we're going to add a step that I don't always make you do, but I think is going to be very important here, and I'll explain why in a few examples. But we're going to check our answers. We don't always do that. We always should, but we're not always careful to do that. 3/4. Now I could go back and plug the 3/4 in. As long as I did this correctly, that'll be the right answer. But what I'm really looking for in this case is not that I did the work right. It's that I don't find an answer that makes it 0 in a denominator. Okay, so remember, if you divide by 0, you get an undefined value. Here I don't have any x's in the denominator to plug this back into, so we're going to be okay. But in a couple examples I'll show you why this is going to be important, so I'm going to keep it on the list for right now. So finally, the 6th step is going to be to write a solution set. Okay, and so our final step is to write out our solution set. There it is. Okay, so let's try this with a slightly more difficult example, again following these same 6 steps. Alright, so let's try it with an example, 7x minus 4 over 5x equals 9 over 5 minus 4 over x. Okay, same 6 steps to solve. We find the LCD, which in this case the LCD is equal to 5x, right? I got 5x, a 5, and an x. So 3 denominators make the LCD 5x. I then multiply both sides of the equation by the 5x, which results in every term getting multiplied by a 5x. Okay. Then we reduce the fractions. So here the 5 and the x both cancel. Here just the 5 cancels, and here just the x cancels. Okay? And so when I go through and simplify and solve, this first fraction just becomes 7x minus 4. The second fraction is 9x. And the third becomes just a minus 20. Right? 4 times 5. Everything else canceled off. And from here we just need to solve. It's a basic linear equation with no fractions now, which is really nice. Add our 4. Those drop out. Subtract 9x. Drop those out. This will be a negative 2x is equal to negative 16. And divide out the negative 2, and you'll get 8 as an answer. Now, here's where we want to make sure, so we just simplified and solve. Here's where we want to make sure to check our answer. If I take this 8 and plug it into the denominators, I get 5 times 8, which is 40. That one doesn't have an x. This one is just an 8. As long as none of those denominators are 0, I'd say we're fine here. And this is a good answer. So my final step is the solution set, which is the set containing 8. Okay. In the next video we'll talk more about checking our answers and seeing what happens when we get a problem.